Okay, so when you're using synthetic division to evaluate a polynomial, you're basically doing synthetic division with the value that you're given, and the remainder is the result of evaluating the polynomial at that value. So when I say evaluate the polynomial, basically that means that I'm asking you to do this, to put the value in for x and see what you get. Yes, and this is the one with the typo, with the double addition, yeah. But this is not the way that you guys are going to find the answer, because the whole point of this question was to show that you knew how to apply synthetic division in this way. So what this question is asking you to do is use synthetic division with that value. And so we need to set up the coefficients in order and make sure that all degrees are accounted for. So we've got 2x to the 5th, 3x to the 4th. There are no x to the 3rds, no x squareds, and I know a lot of people on the test forgot to put those zeros in there. -1 x's, and then a constant of 9. So with synthetic division, the first step we do is drop the first number down. We multiply to what's on the outside and write that underneath the next number. So that will give us -2. And then add straight down. So multiply diagonally, add straight down. 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 This is our remainder. That's what we would get right here if we plugged in -1 to this polynomial. And so 11 is our answer. So that was one application that we learned about with synthetic division. Is that
But do we have to write it up? Do we have to write 2x to the power 5 plus 1 x to the power 4 -1 x to the power 3 plus 1 to the power x to the power 2 -2x minus 11 over x over
so you're
plus 1?
saying, do we have to write the result of the division? And I think you want to make sure that you go down an exponent. So like it started out x to the 5th, so your leading term here would be to the 4th plus x to the 3rd. No, not for this. Not for what this problem is asking.
Okay.
But if you did, this is what it would look like. Plus 11 over, what was I dividing by? I was dividing by
X.
x plus 1 would be what I was dividing by.
How do we know what we're dividing by?
It is the linear factor that would go along with this 0. So if this was an x-intercept at -1, the factor that would go with it would be x plus 1, because -1 plus 1 gives you 0 as a result.
Right.
But for what this question is asking, no, you don't have to show that answer. It's the remainder alone that you're looking for.
Bless you.
You said you need the graph.
I can just sketch a graph. I don't need the actual graph from the test in order to graph it. Okay, identifying characteristics of rational functions. First thing you want to do before anything is write this in factored form, because some of these characteristics are easier to find in standard form and some are easier to find in factored form. The numerator has a greatest common factor of 4, and then in the denominator that would factor to, we need two numbers that multiply to 18 and add to -9, -6, and -3. Now the numerator can factor a little bit further because that's the difference of two squares. So you would have x plus 3, x minus 3 over x minus 6, x minus 3. And on the final, if you come across a problem where you need the factored form in order to find information and you just can't come up with it on your own, you can come up and I'll give you the factored form and then just take off, a point or something on the spot. That way you can still move forward with the problem, and hopefully still have a chance of getting like the rest of it right. So x-intercepts. Do you guys want me to do like notes along with this as well?
Yes, please.
Okay. So, okay, x-intercepts are the x values that make only the numerator equal 0. I say only the numerator because if we look at our numerator and denominator, the x value positive 3 would make the numerator and the denominator be 0 because both the numerator and denominator have that factor. So that's not going to be an x-intercept.
So negative 3 is the only answer.
Correct, coming from this factor right here. This is the one that creates our x-intercept. It would be negative 3. So our x-intercept.
Do you also like graph on the calculator just to make sure?
Sure. Let me find all the information first, and then.
Well, I know. No, you don't have to. I was just asking if we could. Like,
if we could.
Ourselves.
Yeah. I mean, I can show you real quick after we get all the information,
cool.
though.
0? Why would 0 work?
No, that's not. That's the ordered pair. That's the location on the graph. Negative 3, 0.
It's really close to the point.
Yeah. It's a point, so we show it as an ordered pair.
Okay. How do I know 0? Is it always going to be 0?
For the y value of the x-intercept, yes. Just like, let's see.
It's the point?
Yeah.
Right.
Okay.
Right. Just like for the y-intercept, the x value is going to be 0. And we just need to find the y value. And that's actually how you can remember how to find it, too. For the y-intercept. Plug in 0 for x. And for me, it's easier to go back to the standard form and do that rather than the factored form. If we plug in 0 for all the x's, that puts a 0 there, a 0 there, and a 0 there, which just leaves us with negative 36 over 18, which would be negative 2.
Okay.
Vertical asymptotes. Those are the x values that make only the denominator equal 0. So in this case, it would be positive 6. And vertical asymptotes are lines, they're not points. So instead of showing it as an ordered pair, we show it as a mini equation. X equals positive 6.
How do we do that? Sorry, can you show that again?
The vertical asymptote, look at the factored form. And what values would make the denominator be 0? You've got positive 6 from this factor, positive 3 from this factor, but positive 3 also makes the numerator equal 0.
Okay. So vertical asymptotes and x-intercepts are the opposites of each other, basically.
Yes.
Okay.
One of them makes a fraction equal 0, the other one makes an undefined. But both of them are related to making either the top or the bottom equal to 0. The wholes come from the factors that cancel. So the wholes, x values, that make, you end up with 0 over 0. 0 in the numerator, 0 in the denominator. So basically you have a matching factor on top and bottom. That's what causes that to happen. So, and a whole is an ordered pair, it's a point. So the x value would be 3. We get the y value by eliminating the matching factor and then plugging it into what's left. What's left is 4 times x plus 3 over x minus 6. So I will plug my x value of 3 into that. 30 plus 3 over 1 minus 6. And that gives me 24 over -3, which would be -8. A lot of people want to go straight to putting the hole on the x-axis for some reason, but that's not correct. It's got to be on the curve somewhere, and that's how you figure out where on the curve we should be. I think I'm running out of colors. Could do checkerboard. I don't know how that would look. Let's just go back to red again. So the last thing, horizontal or slant asymptote. Horizontal or slant. That comes from the results of long division. One of the other purposes of us learning long division. But you don't actually have to do the full process because you're only interested in the results of the long division. You're not interested in what the remainder would be. And for this one, I don't know if you guys remember the trick that we talked about where if the degrees match on the top and the bottom, then it's just the coefficient of, it's the ratio of the leading coefficients. In this case, the ratio of the leading coefficients would be 4 over 1. We have 4x squared on the top, 1x squared on the bottom.
How do we find that?
Let me pause this for a second. Okay. Let me rewrite my original problem so that we can see what's underneath there again. So it was 4x squared minus 36 over x squared minus 9x plus 18. If I was going to set up the long division, 4x squared minus 36 would go under the division symbol, and then what's in the denominator would go on the outside. And in this process, you would ask yourself, what do you multiply to x squared to get 4x squared? 4. And at that point, we wouldn't be able to take the long division any further. We'd be able to do some calculations and find the remainder, but that's as far as we'd be able to take it. We're already down to a constant number. That's why the horizontal asymptote is 4. It's whatever you would end up with on top here, whatever the result is of the long division.
So sometimes it's not as easy as just looking at
Sometimes you have to take it a little bit further. That's where we end up with oblique asymptotes.
You have to make sure there's no remainder.
Right. Or, I mean, there can be a remainder.
But you have to
But-
make sure it doesn't go further.
Right, yeah. So last thing we have to do then is sketch it. Let's see. If you can remember that. Okay, so if we were going to sketch a graph, x-intercept at -3, 0. Stick that over here. -3, 0. Y-intercept at -2. 0, -2. Vertical asymptote at 6. +6. That's x equals 6. And we've got a hole at 3, -8. 3 down 8. That'd be like down here somewhere. 3, -8. And a horizontal asymptote at 4, +4. Y equals 4. So now, based on all that information, I can sketch a graph of my curve. We've got a curve that goes right here. We want it to touch the hole. We don't want it to go through it though. It sort of skips that spot. And then the other part of the curve would be over here. So really, in reality, if we zoomed out far, far away, the graph would just look like a horizontal line at y equals 4. It's just that the division causes this break in here with some goofy information.
Yeah, my graph does not look like that.
A lot of people's graph did not look like that.
That's a yield.